Hey, welcome guys. This is Mr. Flaherty's YouTube tutorials. Right now, this one is specifically for my secondary Math 1 honors classes. That would be periods 1, 2, 4, and 5. If you are in period 3, you need to go to, there's a different video for yours. So again, secondary Math 1H, 1, 2, 4, and 5. Okay, my goal, guys, is to give you one YouTube per week that describes the two different concepts that you guys get. Remember, I assign 2 assignments each week, and what I want to do is give you a little overview of those 2 assignments, give you a little background with them to enrich the Big Ideas Math. The Big Ideas Math actually does a fantastic job with it. It does nice tutorials. If you follow with it, it does an excellent job, but this is just to give you a little bit, maybe a little bit better background with it. Okay. What I want to do today, guys, is sections 11.4 and 12.1. Those are the 2 assignments that are going to be due for you guys. Remember, they're always due on the following Monday. So these assignments would be due Monday, April 20th. All right. I also want to, I know this has been a tough time, guys, for all of us. To try to teach online, to try to learn online is obviously very different. So hopefully, from what I've been seeing, though, you guys have been doing excellent with the work. I've been getting positive remarks from you guys. So hopefully keep that up. Stay up with it. And I think it's looking good. All right. One other thing, though, when we're doing these videos, if you do need to leave the room, whatever room you're in your house, you're going to have to grab that hall pass. It should be right by your door. So you're going to grab that hall pass. And remember, you got to put it on. And you can't just take it and fling it around. You actually have to wear that so that anybody in your house can see that, yes, you've got permission to be leaving this video. All right. Knowing that, all right. So what I want to do is first do a really quick review, guys, of 11, 1, 2, and 3, which is what you guys had this last couple weeks here. This chapter 11 has been on transformations, which just means a change in a figure's position. You guys looked at 3 different types. You looked at translations, reflections, and rotations. And then they also threw in glide reflections at you guys. So just a really quick overview with this. Remember, with transformations, with a translation is basically also called a glide. You guys learn translation in 2 ways. You guys learn function notation for a translation, which just says it's going to take some coordinate x, y, and maybe it's going to move it to x plus 2, y minus 3. Okay, what this actually means is that every single coordinate is going to move 2 to the right and 3 down. Another way of writing this is in what's called vector notation. In vector notation, this would just be simply written as 2, -3 with the angled brackets. If you use parentheses, that's an ordered pair. This would be vector 2, -3. Visually, what does this do? It moves every single coordinate 2 to the right and 3 down. So if your pre-image, let's say, is the point 2, 4. So the pre-image, let's say, is point A, is the coordinate 2, 4. After a translation of x plus 2y minus 3, that pre-image of A of 2, 4 is going to move 2 to the right and down 3. So if it's going to go 2 right and down 1, 2, 3, it's going to move it to this point right here, which would be the coordinate 4, 1. That point right there, the image of A, is written as A prime. That is the image of A. So the pre-image is A. You do whatever transformation it is, in this case a translation, you get its image. And we say that A gets mapped to A prime. Now on this, for translations, if you draw in the line with the arrow that goes from the pre-image to the image, you get a vector. A vector is basically a ray. It has direction, it has magnitude. And this vector then of 2, -3 is going to move all coordinates over 2, down 3. That was your first one. That is a translation. Okay. The second one we had was a reflection. For a reflection, what you need is the line of reflection. So capital R, let's say we want to reflect it in the x-axis. So the common ones are the x-axis, the y-axis, x equals some value, y is equal to some value, or y equals x. So there's a few different ones you could have. The x-axis, y-axis are probably the simplest ones. That just simply, remember, means you're going to move some point. So let's say the pre-image is the point 3,1 is A. If I reflect it in the x-axis, it's just like taking it and folding it over the x-axis. Its image would be right down here. That would be A prime. So the point 3,1 would get mapped to the point 3, -1, if it's a reflection in the x-axis. If this, let's say, was a reflection in the y-axis, all we do is we're going to take, instead of taking and folding it over the x, we're going to fold it over the y. So it's going to slide 3 to the left here, and it's going to end up, this would be your A prime. You could reflect it in a line, let's say x is equal to, how about x is equal to 1? If x is equal to 1, remember x equals, guys, is a vertical line. X equals is always vertical. So if x equals 1, notice how A, if I fold it over that line, it's 2 to the right, so it's going to go over 2 to the left. So its new image, let's get these other ones out of here. Its new image here, guys, would be the point -1, +1 would be your A prime. And also, if you reflect in a y equals, it's just going to be a horizontal line, and you flip it up or down. One other type of reflection is a reflection in the line y equals x. That's a pretty common one. Y equals x is a line that is a 45-degree line. So if I drew a 45-degree line here, goes right through the origin, this is the line y is equal to x. Some of the points on y equals x would be 1, 1, 2, 2, 3, 3, 4, 4. Now, if I reflect it over that line, remember our original point here looks like it was what? What did we have? 3, 1 here. So if A is the point 3, 1, okay, and I'm going to do a reflection in the line y equals x, it's folding it over that line of reflection there. I don't want you to get confused here. This was a different line of reflection. So here's your y equals x, that 45-degree line. If I folded it over that line, the point 3, 1 is going to get sent to the point 1, 3. This would be A prime. And you'll notice for y equals x, all that happens is you switch the coordinates. 3, 1 gets mapped to 1, 3. So a nice little trick for that one was, that means any xy coordinate is going to get sent to, all you do is flip the coordinates, yx. And in Big Ideas Math, they explain that to you. So that should be, hopefully, review for you guys. Okay, that was reflection. Then a rotation. Rotations can come in a couple different styles here. For rotation, you can do either a 90, a 180, a 270. So let's just look at, suppose we had a 90-degree rotation. They're all going to be about the origin, which simply just means that all the points are going to rotate about the origin. So if I had the point, let's say I have the point 5, 2. So if I have the point 5, 2, and again, let's just call that A. If I do a 90-degree rotation, remember rotations are always going to be counterclockwise unless they specify otherwise. So remember, counterclockwise would be like this. So point A is going to go around the origin in a counterclockwise fashion. So it's going to be like this. So point A is going to move over, rotate over. So if the point here was 5, 2, it's going to move over to -2, +5 is going to be its image. So A is going to move like this, which again makes, if you think about it, this makes a 90-degree angle right here. Here would be your 90-degree angle, whoops, that it makes. And this again would be A prime. So you could have a 90-degree rotation, a 180-degree rotation is just going to take it over to this side. 270 is going to take it all the way over to the fourth quadrant here. Those are rotations. Okay, and then the last one you guys learned was, in this they grouped it with 11.3 was a glide reflection. That is just called a composition. It's a combination of 11.1 and 11.2. So if I had the original point, let's say we have the point 3, 4 is point A. So if I did a glide reflection on this, suppose we glide this, and our glide is, let's suppose it's the vector, how about 2, -1. So that would mean that this point A is going to move 2 to the right and down 1. This would be A prime. And then we do a reflection across. So it's first a glide and then do a reflection in the line. Oh, how about just the x-axis here? So this glide reflection would be A is going to go to A prime. There's our glide. And then we're going to reflect it across the X. It's 3. So we're going to go down 3 here. This point right here would be what's called A double prime. And again, this is a composition, which means basically a combination of 2 transformations, glide, reflections. Okay, that pretty much was the first 3 sections here. One other quick thing that I do need to mention, and that is what is called a rigid motion, because this term is also going to be used in section 11.4. A rigid motion just means the pre-image is congruent to the image. And when we have 2 figures that are congruent, it basically means they're the exact same shape and size. So if you think about it, a translation, you're just sliding it over, it fits right on it. That's a rigid motion. A reflection, you're flipping it, also a rigid motion, and a rotation. Glide reflections, all of the ones we've looked at are rigid motions. The one that we didn't cover, that not in our book actually, is a dilation. That would not be a rigid motion because that means something is getting enlarged or reduced. But that pretty much, guys, should get us really caught up for 11.4, so we're ready to hit that. What I want to do with that is look at it with the big ideas and kind of walk you through that. Okay, guys, so as I mentioned, I want to show you guys what I've been putting on my Google page, and I'm not sure if all of you guys are being able to get there, but I just want to take just a few minutes here. So on the Google page, I had you guys go to Big Ideas Math, and I even put a link in there for the COVID-19 support. So if you go right to that link from my Google page, you will get the COVID-19 support. And Big Ideas Math has done an excellent job with this. And if you guys go down to the student resources, so the bottom right here, you'll notice there are 4 different ones that you guys can go to. So if you go to the Learn About Student Resources, there are many options here with this, and it goes through the Student Edition ebook. And if you scroll down, you guys can hit the play for the 6 through 12. It gives you a little tutorial on that. I'm obviously not going to do that with you, but you can do that on your own. Then you can also go to how to access your online lessons with the Dynamic Student Edition, which I've been talking about also on my page. So the Student Dynamic Edition is really good. And here again is a little tutorial for that for grades 6 through 12. So you can click on that and get a nice tutorial with that.